Good morning, good afternoon, good evening, wherever it is you're tuning in from. This is Sam Knight at Blue Marble Geographics. I'm here with Scott Weber.
Hello.
And today what we're going to be doing is taking a look at the top 5 jobs of the Geographic Calculator version 2023. This is going to be a sort of a general introduction for folks that are new to the software, or maybe you've been using a previous version and you're new to Geographic Calculator version 2023. We'll be going over all the basics of sort of the most common tasks that folks need to do day in, day out with the Geographic Calculator. If you do have any questions during the webinar, please feel free to use the questions panel. It's typically docked on the right side of your screen. You can send in questions. Scott and I will see those, and we'll try to take some as we go, and we'll leave some dedicated time at the end as well. I'm Sam Knight. I'm the Director of Product Management here at Blue Marble Geographics, and Scott is in our QA department. You want to talk about what you do at all, Scott?
Yeah, I'm the lead QA person for the Geographic Calculator application. So I try and make it work correctly for you.
All right. And we are just going to get to it this morning. So let's go ahead and get out of our slideshow. Nope, slideshow is refusing to end. There we go. And here we are in the Geographic Calculator. We're going to shut off our cameras now just to give you full screen view of the calculator. And there we go. Okay, so the top 5 jobs of the Geographic Calculator. If you're here, I assume you're generally familiar with the fact that Geographic Calculator is a coordinate conversion tool, datum transformations, reprojections from one coordinate system to another, all those sorts of geodetics operations. It does many, many different things, and it does it on different types of data. It does it with different types of coordinate systems. But there are a few things that folks tell us over and over are the main things they come to the Geographic Calculator for, and that's what we're going to be talking about today. If you are completely new to the Geographic Calculator and you don't know what any of this stuff is, what you're going to see here on screen right now on the start page is a sort of a little bit of an entry to our documentation. So down the left-hand side of the screen here, you'll see your project manager, and those are all the different types of jobs. Mine are going to look a little different from yours because I have a customized workspace here, and eventually you might customize your workspace as well. Within this middle section where you see the kind of grayed out icons of those and some of the same terms, all of these are the different types of jobs. If you click on any one of these, it will tell you exactly what that type of job is for, the types of input data it can handle for input and output. And then at the top of this, you'll see there's a file field. If you simply put a piece of data in that field, so say you have an Excel sheet, or say you have a map info tab file, for example, or something else, whatever type of data you put in there, it will narrow this list down to just the jobs that apply to that and will help you hone in on the particular thing you're looking for in the calculator. What we're going to be taking a look at today are the sort of the most common things. And as Scott and I were talking about this, we got into a little bit of a debate about which the 5th item should be for today. So we're going to talk about sort of the big obvious heavy hitters. We're going to talk about the interactive conversions, point database conversions, vector conversions, and raster conversions. That gets us up to 4, and then we had a good long talk about number 5. So we might talk about a couple extra things in there because there's a lot of different tools here in the Geographic Calculator. And they all relate to each other through some sort of common coordinate system handling tools. So we're going to warm up on the interactive conversions, and by the time we get to the end, you can probably figure out why it is we had such a conversation about what that 5th job should be. Here on the interactive conversion, we're talking about single point conversions. There are a few other operations up here as well. You'll see forward and inverse calculations. These are really, you can think of them as, a lot of folks call these surface trigonometry, and it's sort of trigonometry. Forward and inverse relate to distance and azimuth between points on the surface of your coordinate system. So on the surface of a datum typically can be done a little bit at elevation or below the surface by adding in some heights, but what a lot of folks simply refer to as surface trig. We're going to be focusing on the conversions because that is by far head and shoulders the most common thing that anybody does in the geographic calculator. To a lot of people, the interactive job is the geographic calculator. This and the point database conversions we'll be getting to next. So here we're talking about entering one single numeric coordinate. And in this case, my input is on the left over here. And you'll notice that I do have an operation direction at the very top of the screen there. You'll see we can go left to right or right to left, however you choose. And over here on the right-hand side is where our output is going to go. You'll see I have some coordinates already punched in here. So I have some values, I have some coordinate systems. We're going to start by backing up just a step and how we actually get this stuff in here. So it really all starts with the coordinate system selection boxes, what we call the blue boxes down at the bottom of the screen. If you're totally new to the geographic calculator, you're going to notice that the blue boxes are present on basically every job in the calculator. This is really the core tools of the application. So we have a system, and that is sort of like the name of the entire coordinate system, whether it's going to be a lat-long system or whether it's going to be a common projection, maybe a UTM zone or a state plane zone or some national coordinate system that you have wherever you happen to be. There's other information that goes along with that. So there's a horizontal datum. There might be a date if you're talking about a time-based coordinate system. There's, of course, things like units and whether or not we're doing a vertical coordinate system at the bottom, and then some units for that and some formatting. So these are sort of the common pieces you're going to see on every single job of the calculator because it all relates to some geodetic definition of where it is our data happens to be. Now here on the interactive job, it's nice and simple. We just have one single coordinate that we're going to work with. I've punched in a basic latitude, longitude value, and this is roughly in the neighborhood of the planet where Scott and I are here in Maine in the States. And we need to define what coordinate system that is. So what those lat-long coordinates relate to. So to get into these, I'm going to double click on that top box, and it's going to ask me if I would like to narrow down my available coordinate systems based on a geographic area. So if you're starting from scratch in here, you can click a point on a map if you choose, or you can drag a box on a map and say, I'm in this chunk of the world, only give me the coordinate systems that apply to here. I'm going to say no to this. And once you get comfortable with the application, you can make your choice and you can turn off that prompt and have it just simply do whatever your preference is. I'm going to say no to this and let it show me the full list of coordinate systems. You're going to see me dragging a few things in off screen here because I'm working on a second monitor, and so a lot of my dialogues are popping up on my primary. So up pops the coordinate system selection dialog. And if you're new to the calculator, this is sort of one of the most core pieces of the application. This is how we handle selection, finding all of the definitions that we have in the database. So there's somewhere north of 5,000 coordinate systems in here, and they're broken down into various categories. So you'll see the sort of the major categories, the ones everybody thinks of commonly are geodetic. Those are going to be our latitude, longitude based systems. Projected coordinate systems, those are everything from those national grids to UTM zones, regional projections, things like that. Doesn't matter what scale they're at, they're all grouped under the projected category. There's a few others in here that are a little less common. Folks that work in surveying, they work in the geodetics end of things, more commonly might be familiar with geocentric coordinate systems. Now those are commonly called a few different things. Earth-centered, Earth-fixed is one. Some folks simply call them 3D Cartesian. Geocentric coordinates is another name. XYZ, a few different names in the common vernacular. These are basically all the same datum names that we see under the geodetic list. It's simply a Cartesian reference rather than a latitude longitude reference. Up top, you'll see fitted. And when you click on that, you're not going to see anything. This is a folder for a special type of coordinate system where we're using polynomial equations to map up a transformation against a local coordinate system that's a ground grid, like a survey grid or an engineering plan, using control data to map that up against a geodetically based lat-long system or projected system, and so on. We'll maybe come back to that at the end because this one gets into the debate Scott and I had about the fifth job. And then down at the bottom, string coordinates. Now a string coordinate system could be lat-long based, it could be projection based. What they are is they're sort of commonly used for national systems or regional systems that are broken up into grid zones that have like letter designations for certain areas of the grid. And if you've ever worked with, say, British National Grid, that's probably one of the most common, or if you've used the Common Military Grid Reference System, MGRS, that's another one that folks have bumped into. You'll see a lot of them here on screen that are red. They say ATS, boundary measurement. That's a specialized group of coordinate systems used for townships and ranges in the area of Alberta in Canada. That's the Alberta Township System. So there's a lot of different ways that we wrap up other coordinates with these other designations, breaking them down into zones. And that's what you'll find under the string category. What we're looking for here is a nice, simple lat-long reference. So we're going to go to NAD 27, which is what we had selected in here. And you'll notice that under the geodetic category, they're broken out by regions. And there's two ways to view this. And there's a simple checkbox up here in the top right of the screen to include subfolders in your view. So right now, I have geodetics selected. That's at the very top. If I toggle off include subfolders, you see everything goes away. The difference here is if you are viewing the subfolders, it's more like looking at a Venn diagram. You're going to see the contents of the folder you've selected and everything that comes below that in the hierarchy of the folders of the tree. So in geodetic, there's nothing up at that very top level. If you want any regional area, you have to click into whichever area that is. However, if we do something like North America, you'll see there are 3 coordinate systems at that top level, and there's the one I want right there, NAD 27. If I toggle on include subfolders, you'll see every coordinate system used anywhere within North America as well. So any small regional coordinate system that doesn't apply to the entire area. That's the way the hierarchy view works there. So this is a newer tool. We just added this in version 2023 of Geographic Calculator. And it's a very powerful way to add some more flexibility to navigating through here. There are also search tools. We're not going to get into that a lot today. If you want to learn more about the search tools, particularly the advanced search features, I would suggest looking on the YouTube channel for a video that we did a short while ago introducing all the new features of Geographic Calculator.
And this new interface is a little bit more complex than the older one. And if you're used to the older one, it seems a little daunting at first, but really after using it for a little while, it is just far and above better than the old way of searching through these systems.
Yep, that includes subfolders option took us here, a few minutes to get used to it, and now I can't live without it.
Yeah.
Scott and I are regularly going back and working in old versions to make sure things are still working the way they're supposed to be, and I miss it every time I roll back to a previous release. So it's a new way of getting through here, much more powerful than our old view. So again, I'm looking for that NAD 27 coordinate system right there. If I have any questions about if I've got the right system, we can open that up by right-clicking on it and saying View Info. And that's going to open up the definition panel for this that tells us all of the nuts and bolts that make this thing a particular definition. So there's 3 tabs here. You'll see identifiers, details, and history. Identifiers is one of the most useful for making sure you've got the thing that you're looking for. You can cross-reference at the bottom of the screen there against all of these other types of database IDs. So you'll see the CS map section that is corresponding to the open source CS map libraries that are found in some other software. You'll see things like the EPSG codes, ER mapper codes that are found in things like AirDOS software for referencing coordinate systems, Esri coordinate systems, SRIDs down at the bottom from Oracle spatial databases, and so on. Whatever type of cross-reference we can find will be matched against parameters and put in that list at the bottom. The remarks in that middle section just give you a little extra information, and a lot of that comes from the EPSG database. So gives you a little more commentary about maybe where it's used, maybe how it was derived. There's a variety of information that you can find in there. The real nuts and bolts are here on the details panel. So we're looking at a geodetic coordinate system, so the parameters are actually fairly simple. There is a usage, which gives us the area of use on the planet. And the intended scope. So, whether it's for military purposes or geodetic surveying, for example, you'll see a few different terms associated there under the usage definitions. And then a point style, which is basically just a fancy wrapper of units and what type of directions we have in the coordinate system. So you'll see ellipsoidal 2D coordinate system, axes, latitude, and longitude. So it's just telling us that this is a latitude, longitude type of coordinate system. Our positive directions are north and east, and the units of measure are degrees. So it's basically a big wrapper of the units that we commonly think of. And then lastly, on the lat-long systems, you'll see the datum. And so that really provides us most of what we need for a geodetic coordinate system. It's the size and shape of the ellipsoid. So the datum contains the ellipsoid contains the shape of the Earth that we have, and the datum also has that origin for us. Now, if I'm looking at a particular datum and I'm seeing, okay, North American datum of 1927, is that really the one that I want? I know I need a particular ellipsoid. You can click on the information button next to that set of parameters and open up the definition of the ellipsoid itself, and we can say, oh, okay, yes, this is the ellipsoid that is Clark 1866 under that datum. Let's double check those parameters. I'll click the info one more time. We can actually see all of the full parameters, the dimensions that define the size and shape of that datum that we're building our coordinate system on. So all of the parameters here are completely exposed to the end user. You can find anything you need to find out. There's really nothing hidden about any coordinate system in here. So if you still have all of that same question, am I looking at the right thing? You can always go back to the identifiers and try to match up those things against other locations and say, okay, if I'm using this definition from this software, let's see if there's something else I can match on. There shouldn't be any question by the end of that. So once we've inspected all the parameters that we're looking for, we come back, we say, okay, I've got my NAD 27 coordinate system. I know that's the thing I'm looking for because I've validated everything about it. We can either just simply double click on that or just select it and click the OK button down at the bottom. That's going to return us back to the main screen. Now, if you're working in a modern coordinate system, and by modern, I mean like within the GPS era from the 1980s up until about now, some of those coordinate systems have time-based components to them. If you are working in one of those reference systems, you'll see the middle box there, the date. That is going to set what is called the epoch for a time-based coordinate. You set your basically day, month, and year in there for locating that position in the time reference. You do that for the input and the output, and if there is a time component available for that, it will come up in the transformations. On the output side, you'll see I have a different coordinate system here. I have NAD 83, UTM zone 19, a common enough coordinate system for anywhere in the world has a UTM zone describing it. Extremely common coordinate systems. We did the same thing to get that. I'm not going to step all the way down through the tree, but We double clicked on that. We say we have the choice about filtering by area. Again, I'm going to say no. And we browse down through the projection list to find the folder containing the particular datum that I want and the NAD83 UTM-19. I could click the info on that if we wanted to, validate the parameters, make sure that the codes match for what I'm looking for, and so on. So we grab onto that and say okay to come back to the main screen. We're most of the way there now. What is still missing is you'll notice that blue box in the center has nothing in it, and that is the coordinate transformation. So Geographic Calculator is what we call a late bound coordinate transformation. That is, the datums for input and output do not relate to each other in any way. If they are different, we need to establish how to relate those. That is one of the most important choices you as the operator have to make. So the process is pretty much the same. If you have input data, we will factor that in. As we double click the coordinate transformation box, that's going to open up the horizontal transformation selection dialog. The dialog works basically the same way as the coordinate system picker, except there's a map on the bottom to show you where in the world the system is intended to be used. So its area of coverage, or the transformation rather. So we can take a look at any specific transformations that we have in there. If you select a transformation, it will show you that polygon of where that transformation is valid. Now, if you enter a coordinate and you pick a transformation and you see that you are not in the right part of the world with the transformations that are selected, that's a good indication that you need to back up a step and double check that value that you've entered in. Maybe you've simply left a digit out. Maybe you put the decimal point in the wrong place, those types of errors. You should see polygons surrounding the area that your data is in, whether it is a single point or whether it's a vector or a raster file or whatever you've got. Now the categories down the left here are a little different. These are not just region-based. So you'll see we have what we call datum transformations. These are sort of our conventional datum transformations. This is a grid file-based transformation here in the States. This is our older national transformation called NADCON. A lot of folks here in the US are familiar with these. That is one transformation. And then you'll see there are some generated transformations. And so these are different combinations of transformations that link two transformations together, stopping at a datum that it will be in the middle. So these all say via WGS84. So if I click on any of these categories, you'll see it's going to connect the dots between NAD27 to WGS84 and then WGS84 to NAD83. Sometimes the names don't always line up as we group those in there. As long as there is a common datum, they are reversible and will link in the proper order. So these allow us to do two-step transformations to get from the source to the target, and those are also very common. Just because they're generated transformations, putting two together does not mean they're any better or worse. It just means that's maybe how you're going to get there sometimes. And we have a few special categories like NADCON 5 for here in the States. So NADCON 5 is our new national transformation. This is the survey standard if you're working with survey quality data and you have to do any type of reporting on that data. And you'll see NADCON 5 shows up a little bit differently here. It shows up blue, and it's off by itself. It's really a special type of transformation that is different than a lot of the others because this links several transformations together. The shortest way to sort of explain this is that if you are working in the US and you are working with data in any of the US survey datums, all the way back to the US standard datum pre-NAD27, any US survey data, you should be using the NADCON 5 method. So if you see that light up as a combination for the data that you've entered in the US, that is your best shot. If you are working with other data, so I know we have folks from all over the world on the call this morning, you're going to be looking mainly under the data source transformations here in the datum folder and in the generated transformations folder. Within any of those, in these other categories, you're going to see some extra information like accuracy and the area of use as a description of where on the planet these transformations are good. The accuracy is basically the confidence of the positioning of that transformation. And these vary wildly all over the planet. It depends on where you are, what coordinate systems you have access to, and what type of surveying has been done in that part of the world. These are all standard parameters that come from the EPSG database or various national authorities and so on. But you use that accuracy information to sort of let the most accurate ones float to the top. So the way this works is the smallest number is the best. So if you have one that is accurate to 0.15 meters up here, that's 15 centimeters, and you might see one right next to it that's only accurate to about 10 meters. The one that is 0.15 meters is going to have a higher confidence than the one that is 10 meters, and so on. Okay, so let's go ahead and grab onto our NADCON 5 because I know we're here in the States. I'm just going to simply double click that, and it brings us back to our main screen, tells us the choice that we've made. And you'll notice that everything is red on screen. So I had some old coordinates that I had calculated before, but I've been changing stuff on screen. So all my coordinates turn red. As soon as I click calculate, all of that is going to display in black, and I'm going to get all of the various fields populated with that. Now, depending on the coordinate system you've selected, you're going to see different things. So if I have a projection on output like I do, you're going to see things like base latitude and longitude light up, maybe, if you have the preference for that turned on. So this is a user preference that I have enabled that shows me my base latitude and longitude anytime I work with a projection. And I've also got some special fields lighting up because I used the NADCON 5 transformations. So I have these extra uncertainty values that light up for that particular transformation. You're going to see different fields come and go depending on the coordinate systems and the transformations that you're using. That's going to be true of the NADCON 5s. That's going to be true of anything time-based, whether it's horizontal time-dependent positioning here in North America, or whether that is, say, a 14 parameter time-based transformation in other parts of the world. All of those fields will come and go, and we basically try to give you as much of the metadata about that point as we can as we're going. There are various ways to get the data out of this job. We can right-click in the sort of surrounding area of the coordinate point definition. You'll see we can copy that point. That's going to allow us to copy and paste that between jobs in the calculator, or just simply out to a text box or something like that if you want to get a text readout of that. If you have Google Earth installed, that is not the cloud browser-based version, but if you actually have installed Google Earth on your desktop or laptop, whatever you're working on, you can click that and it will launch that point. It'll basically take a WGS84 version of that point, throw it on the map for you as a good sanity check. Or you can also click Save As, and that will allow you to save that point as a vector type. So you could save it out as, say, a shapefile or something, to load that in as a sanity check somewhere else external to the calculator. There is also a printed report option up there. If you have a print driver installed on your machine, you'll have the options to do a printed report. I'm just going to do a quick print preview there with our defaults. And it's coming up behind my meeting controls. There we go. A quick one-page report of the transformation that's been done. And there are various levels of detail that you can explore, whether you want just the results or whether you want all the parameters that were involved as well. That can be sent out as a PDF, that can be sent out to a paper hard copy, whatever it is you're looking for in that report. So these are the basic nuts and bolts we're going to apply in all of those other jobs. Is there anything we're saving in here, Scott, before we move on?
You might just want to talk about the base latitude, longitude. Those are new to version 2023 to be able to have the base latitude, longitude when you have a projected coordinate system selected. You imply that the uncertainties are related to the NADCON 5 and will only show up when that particular transformation is selected. And so to turn the base latitude longitude off, you would go to options preferences, and you'll find that a checkbox there to.
Let's go ahead and pop that open. You'll see under, I did that kind of quick, options, and in the preferences on the general tab, you'll see partway down there, show geodetic base coordinates. And if you simply toggle that on, you will get that base latitude and base longitude display with your projections on the way out.
So that's been requested by a number of users, and we have added it, but it is a preference that has to be turned on.
Yes, yep. And personally, I've of course been using the calculator for many years at this point. I love that setting. That is one of my favorite new things that we've put in here in a long time. I was surprised how much I use that day in, day out, just as a sanity check when I'm doing a conversion check to make sure that I'm working between two projected coordinate systems, and I want to make sure that I'm thinking of a user years ago who would regularly call up and say, I'm working in Minnesota, but my data is showing up in Mongolia again. I totally could have used the base lat and long back in those days of figuring out what was gone wrong with that data. So that's a good handy one. All right, so we're going to take those pieces, particularly the coordinate system selection and the transformation selection pieces, and we're going to hop over to point database. Now, within the point database job, here we're talking about a lot of coordinates at one time. So it could be, maybe it's just a few, maybe you've got a few points that you've marked out with a GPS in the field and you have a simple Excel sheet. Maybe you have millions of points that are coming from some maybe legacy LiDAR data before common LiDAR scanners used binary formats, and you've got a massive ASCII table of data that is gigabytes in size. Doesn't matter, the calculator doesn't care if you've got 5 points or if you've got 5 million points. We're talking about spreadsheets. So anything that you've got in sort of any of the common formats, we'll just take a quick look at the list there. So you'll see things like, Access and Excel tables, various versions of those. So in more recent times, folks have been starting to use open document spreadsheets, ODS files. It's basically kind of like an open source Excel type thing. Some of the seismic formats for if you have seismic data that is sometimes a little more poorly structured. We'll also take a quick look at the seismic job for cleanly structured data, but then all of your sort of common expected ASCII table types, CSV, TSV, and so on, or DBF, for example, is another good one of an older data type. There's also the ability to format your own ASCII data in here. So one of the things we do in our training classes is we take a look at importing custom structured ASCII data. Maybe it's delimited, maybe it's fixed width data, maybe it has variable length headers and all sorts of things like that. Those tools you're going to find under the options menu for text file schemes. What we're going to be taking a look today is the basics of setting up your columns and so on in here. So you simply find whatever whatever type of data that we're going to be bringing in. So I'm going to grab onto an Excel sheet and I'm going to load that right in here. And it gives us a simple prompt for some of these formats. So if you have an ASCII file that clearly defines what the structure is, whether it has a header or not, it will use those rules. For the formats such as Microsoft Excel, maybe you've got a header, maybe you don't. There's no rules about that. So I know this data does have a header in there, and it's going to load that right in there. You'll see my first couple of columns here. I've got an X and a Y, and I know because of the metadata with my file that is a UTM zone set of coordinate systems. With Excel data, any spreadsheet type data, this is one of the tricky things about it. You do need to know what the coordinate system is, because to the calculator, it's all just numbers. Coordinates are not exclusive. They can exist in similar coordinate ranges all over the planet, centered on different locations. You have to actually know what that CRS is in order to properly transform and utilize the data. So we're making the assumption that you have done the work to find out, what the metadata says, or you've talked to the surveyor who gave you the data. Maybe you are the surveyor who got the data. You have to know what those values actually represent. You need to be confident that X is actually east and Y is actually north, or whatever you use for the designation in your parts of the world, because we don't all agree about what some of those column names mean. It's important to know where your eastings are, where your northings are, or if you're in an alternate part of the planet, you need to know where your westings and southings are, for example. So it's up to you to know the structure of that data. The tools are all here to do the work for you. So here I have this is a spreadsheet that we pulled down from our local mapping authorities here in Maine, and this is coordinates of places where you can publicly launch a boat into a body of water. So it's simply position locations of where those boat ramps are accessing public waterways. And as such, there's all kinds of extra data in here. So you see this thing that is, county code, the towns, various numbers and stuff that don't mean anything in terms of the coordinates. It's essentially just attribute data. All of that stuff just comes along for the ride. We don't care that it's there. It doesn't affect the processing in any way. What the calculator is concerned with is what the columns actually are that contain the data. So we go ahead and set up our coordinate systems, set up our transformation, just like we did on the interactive job. We're just going to do a lot of conversions, ripping down the columns in the data. So on our input, you'll see down at the left-hand side here, there are fields for our northing and our easting because I'm using a projection. If these were lat longs, you'd see latitude and longitude. And the drop downs here are going to correspond to the inputs of all of the column names. If you don't have any column names, if there's no header in your data, you're simply going to see entries like C1, C2, C3, and so on. You can always rename those and it will change the names that you see in the drop downs. That's up to you and how you want to interact with that data. So in this data, I know that the Y column has my northings and the X column has my eastings. If I wanted to also calculate out my source, the base coordinates, like I did on the interactive job, I could add some columns in for that, or I could add some placeholders in before I even loaded the data if I wanted to do that. I'm going to skip that for now, move over to the output side. So my output is in latitude and longitude. You'll see those names. If you look at the table, I don't actually have anywhere to put that data right now. There's no columns for that. So you simply come down to the bottom of the drop down and you'll see add new column. And so here I'm going to put my output lat, and you can name these whatever you like. And I'm going to add, I'm going to add output long. There's not really a limitation on the names of those, anything like that. You're free to insert them in different places. You can drag them around to save them out, however you want to do that. But the coordinate system pieces are just like the interactive job. If you can work on the interactive job, you can work anywhere in the calculator. So we've set up our columns for the outputs. The northeast and ups that you'll see here relate to a time-based transformation that I actually have. Those are some velocities of motion of a time-based transformation that I selected in here. I'm going to hit preview, and you'll see it fills in all of those lats and longs for us. The formats for those data, they're coming out as decimal degrees. If I wanted to see something else, I can click the format button down there, and on geodetic coordinates, I could pick any of the other formats for degrees that we wanted. If you want them in degrees, minutes, seconds, or maybe decimal minutes if you're working with a GPS unit, prefix, suffix, symbols, all that kind of stuff. However you want to see that is right there on the format button. Likewise, if you're bringing in lats and longs, you use the format button on the left-hand side there to help us interpret the data. So you've got to be careful with degrees, minutes, and seconds, particularly that the formatting is being read properly, because it is all just numbers to us. We have to parse out all of the pieces of those. And these are free text entry data formats that we're talking about. So there's a little extra complication there. Now, before I hit preview, and you'll see that it just calculates what's in the sheet for me. When I'm actually going to save this out, if I just want to write out an Excel sheet right away, what I'm going to do is use the field at the bottom for the output data. And I'll go ahead and give that a file name, locate it wherever I'm going to save that out. And then I will instead hit process, and that's going to run that whole job. And the reason we use preview and process here is preview is only active inside the calculator. It's giving you a visual on the screen. It's not actually doing anything to the source file that you've loaded in. To save data out here, we always write a new file. We never overwrite the originals. So your inputs are safe, and it's up to you to do a save as through this process to make a new file containing your output coordinates. It will let you overwrite a file, but we throw up a few barriers and make sure that everything we do is essentially a save as rather than a save. If you're dealing with a very large file, we have this option up here to only load the first X number of records, and you choose what that is. If you're loading data that goes beyond 100,000 rows, by default, we'll kind of stop it on the way in and say, hey, it looks like you're loading a whole lot of data. Do you really want to put it all into the grid here, or do you just want to run it in the background? There is no limitation on the volume of data that Calculator can run. But if you're going to be running, gigabytes of data, instead of trying to look at it all in the grid here, it's really a much better idea to partially load that data, and it will run the entire file in the background as you do the full process on it. There are
Sam,
some
let
other.
me jump in here.
Yep, please do.
A common question that comes in is, why can't a spreadsheet type file be read in with something like a well-known text or PRJ, projection definition, so that the user doesn't have to specify it manually? And the reason for that is that back when we first loaded the data in, the input columns are not yet selected, and there could be multiple columns, like there could be projected and geodetic coordinate columns in the same file. There could even be coordinates represented in different projections or datums, geodetic coordinate systems. So Calculator has no way of knowing which columns you're going to be selecting, and so it can't pre-select which coordinate system it should use on input. And so we have a batch mode where you can process many files at the same time, and it would be great if you could have it automatically read in what coordinate system should be used, but it's just not possible since the columns aren't selected until the user actually goes in and selects them.
Yep, and that's a very important thing to remember about the PDC job in general, is that we're dealing with data that it's really non-spatial data formats. So Microsoft Excel was never intended to be used as a spatial data format. And when you think about loading this data in, we say, okay, well, this Excel sheet, it very clearly has X's and Y's in that column. There are many, many numeric columns in here. And when we write this data out, now it's going to have those two sets of projections, or well, two coordinate systems. One is our projected values, and some are our lat long values. So these, when we're mixing these into the spatial types world, it really does take a little extra care. You can, if you do have that well-known text file or a PRJ file, for example, and you've got that with the data and you want to use that, all you have to do is drag and drop your PRJ file right onto one of these controls, and you'll see that set your coordinate system. So there are some time savers in there that we don't really have time to get into today. Those, you'll find some of those in some of our other webinars. But that's a good point. Thanks for jumping in with that. So next up, moving along here, it actually gets simpler from here. So if you can comfortably work on the point database job, you'll have no trouble with the vector job or the raster job. The vector job is actually our simplest place to work here in the geographic calculator. Also, one of our big heavy hitters. A lot of folks set these up. Like Scott mentioned, we have a batch operation for all of these. I'll just mention it here before we even get started. You set up one individual job, and you can right click on that and say batch add. and it actually uses all the settings from whichever job you've set, and it just asks you what other data you want to add to that and some folder selections for where you're going to write it out and some naming options, basic things like that. So those, basically any job type can be run in batch, however you want to do that. So on the vector data job, we have sort of common formats that are supported in there. I'll just drop the list down. You'll see everything from AutoCAD to some of the more specific stuff that folks use. Folks in the US might remember the old Tigerline format, but some of the common stuff, shape files, map info formats, AutoCAD, DXF, DWG, DGN, GPS files coming in the GPS exchange format, and so on. Number of different types of sort of common popular vector formats. If you have something a little more specialized that's not supported here in the calculator, take a look at our global mapper application, which actually supports 300 formats of data. That is our desktop GIS platform. And if you've got calculator and global mapper together, you can use the geodetics of calculator coupled with the mapping abilities and the format support in global mapper in what we call geocalc mode to really bring some of that power out. So all of those sort of common formats that we have here on the vector job, in this case, I have loaded a simple shape file that I downloaded from our state authorities here in Maine. You'll see a little thumbnail preview of that over on the right. If we double click on that, it's going to pop open our viewer and just give you a quick preview of that file. This is a color viewer, so a shape file doesn't actually carry any appearance information with it. If you're working with a format like an AutoCAD format, for example, that can have multiple layers, multiple colors, you'll see all of that stuff reflected here in the viewer. The coordinate transformation parts of this work exactly the same as they do on the interactive job and the point database job. So you have your coordinate system for input, output, and your transformation. And there's just a couple other options in here. You'll see there's an option to perform a coordinate system change. And you say, well, this is the calculator. Why might you not want to do that? You can also perform a manual transformation, which is a sort of a manual mathematical manipulation of the values in a file. You might do that if you need to put something like a fixed offset in, or you could also say none. And none might be used if you're simply going to do a batch of conversions. Say I download a whole bunch of shape files and I need to convert those all out to map info tab if I'm going to be taking those into a different GIS environment, or something else, maybe a batch conversion from shape to say KML for display in Google Earth, something like that. So there's a few options around the coordinate systems. If you pick none, all your coordinate system settings just kind of gray out. You don't get to do anything there. The default is to do a coordinate system change at the same time. So those tools work exactly the same. The output settings, you're not stuck to the format. So you'll see my example here is we're going from a shape file to an AutoCAD file. So it's going to come out because I'm going shape in and it doesn't have any appearance data. It's simply going to come out with the sort of normal black lines as the AutoCAD. If you're going the other way around, if you're starting with a colorful appearance format and you're going to something that does not store that, you're going to get those defaults out. It's a mix and match across all of those different types of formats. The process here is again just the same. We double click to select our coordinate transformations, and we find what we've got available for that data. And as we process our files, you'll see the progress bars pop up just like they do for the PDC job. And we can also then take our output and open that in the viewer. And there's some options. I've already got a viewer tab open, and I'm going to say let's take a look at this in a new tab. And you'll notice the aspect is very different, and that is because of the coordinate transformation I've done. Our viewer here in the calculator specifically does not reproject things for display. We are coordinate system completely ignorant of the coordinate system, and that is specifically for testing overlay to make sure your coordinates are in the right ranges and that you have not made any mistakes. This is not intended to be a map composer where we're going to just seamlessly load multiple coordinate systems on top of each other. Here, it specifically loads them in whatever the projection it is, so that if your data does not all line up, it doesn't line up. If you want to do a stack 5 different projections on top of each other and compose a, a pleasing looking map. That's what Global Mapper is for. Here in the calculator, this is a quality control viewer. So that's the vector job. The raster job is, again, very, very similar and also a little bit simpler. So within the raster job, there's a handful of formats that we see. You'll see a whole bunch of different extensions out there. Everything from JPEG 2000 is probably the most common format we hear about these days. Lizard Text Mr. SID format, ECW format, old school JPEG, GeoTIFF, regular TIFF, bitmaps, PNGs, all of the sort of common imagery formats. Some of the weirder stuff too. So BIL files, for example, there's a few other random formats in there. All of those can be transformed, assuming that the data is georeferenced. If you need to apply a georeference, so maybe you've just freshly scanned some imagery or some old historic maps or something like that, and they don't actually have a reference file for them, you can use the georeference tool and apply positions to that. So you'll see mine is georeferenced and it's referenced at the corners. If you have, again, fresh data, you can build your list of control points down at the bottom to geotag that and then apply a transformation to rectify that to your chosen coordinate system. The georeferencer is much like the georeferencer you'll find in many tools. Has comprehensive tools for plotting out the various positional errors in there. And it is actually, I've used a lot of different georeferencing tools, and this is actually my favorite that I've worked with in any application. There's no manual stretching stuff around and eyeballing things. It is, you put in your specific point marker locations and we figure out the math to give you a numeric quality control rather than just kind of eyeballing it and saying, yeah, it pretty much lines up. So it's a very nice, powerful, pretty flexible georeference tool. Once you've applied that georeference, you simply come right back to that raster transform job and off you go. You pick your output formats, and there's really just a few things left to do in there. Things like setting the transformation area, and that's if you're going to apply any cropping to that image and so on. Not a ton of options that you need to worry about. There are some basic output preferences on that tab as well. So what kind of reference data do you want to put out? Choice of resampling methods, background colors, and so on. The defaults on there will basically, you don't really need to sweat the preferences unless you want to worry about a background color, and that's really probably the most common thing that folks might be changing in the preferences. Let's see, I see a question come in. Does it transform the datum of the raster? If you are working with a raster type like a DEM file, for example, it will actually convert the vertical. And I think I've got one over here in my list. Yeah, I do. So this is a version of a saved raster job that I've got, and you'll see it's actually got a shaded DEM layer. And when I pick one of those 3D capable formats, you'll see it lights up the vertical transformations with those. So you can do the geoid conversions between either ellipsoid to geoid or geoid to geoid or ellipsoid to ellipsoid, whatever your combination happens to be. So it does do the verticals as well. Okay, I have been talking a lot and kind of quickly there. Scott, is there anything you wanna add?
I was just going to add what Benjamin just asked about the verticals. So
okay, so now here we are. We're at number 5, Scott. So Scott and I had a good talk about this, and it was we were thinking either point database best fit or the seismic survey conversions. And I think number 5, what it comes down to is it depends on who you are. If you work with seismic data conversion all day long, the seismic job is going to be your number 5. Seismic data is very, very much like regular point database data. It looks like a spreadsheet. What the data is often structured at is an ASCII file. So it's basically a highly structured ASCII file fixed with point database data. However, it is very rigidly defined. So Scott and I were talking about how In an Excel sheet, you don't know where the coordinates are, and you might have multiple sets. In a seismic file, you have very specific locations. We know where those coordinates are in these files. So on the seismic survey conversion, there are some subtle differences here between this and the regular, what we call the PDC job, the point database conversion job. On the seismic job, we're talking about formats like SEG or UCOA or the P111 data format. That's a little more modern format. These are all ASCII based. They all have very rigid structures. However, there's variation. So when we load in seismic data, you'll see, I'm just going to reload our file here. When we load in seismic data, there's a prompt that comes up and it says, do you want to use the scheme selected in the preferences to load the file? So in our preferences, there's a whole section about seismic data. And for this file type, SEG, there is a preference that says when you load an SEG file, use this particular import scheme, and it has structure on the header of that data, how the columns are identified, where the spatial coordinates are, and so on. If you load data in, my typical workflow is to first load it using the normal scheme and just see what happens. So I'm going to say, yes, let's go ahead and use that scheme. And for this particular data, I can see that it starts on shot point 110. And if I open up the header editor for this data and I scroll down to the very bottom, I can see it's missing some of that data. Some of the data itself is coming into the header because I know this is supposed to start on 101. So what I might do is as I load that data, instead of using my default scheme, I might say, no, we're gonna manually bring this in coming through the text file reader, and it allows us to manipulate how we actually read these. And in this case, just a very quick example, I know that I need to modify my header, and if I modify my header, suddenly things will get a little bit more comfortable when I'm looking at my data. So this has a slightly bad format coming in. We can see the end of my header and the start of my data with one simple modification on how much of the header follows the header marker of H. I can step through there, I can see where all the column breaks are, and then load my data and see that the shot point number is now correct. This is just a super quick example of seismic survey conversion. This allows us to realign data that has little variations in it. And the reason I'm always a little on the fence about whether seismic survey is, number 5 or whether something else is number 5 is because it's so similar to PDC. It's just a little bit specialized. That's the thing. If you work in the seismic industry, this is probably actually like your number 3 top job. The formats get cleaned up on their way out. So we load the data in. If I write this back out to a seg, it's going to use that output scheme as it goes. It's going to align it so that the header comes out nice and clean without the little bobbles in it. But if your data is really messed up, and this happens in industry all the time, the data structure gets really messed up, you can still more manually load it into a regular PDC job, straighten it out as best you can, and then pump that back out with your manual formatting applied to it. So this is really a special case of the PDC job. And where Scott was kind of leaning about what number 5 was, I think we had a question come in about it a little earlier.
Yes.
We said we try to get to it, is the point database best fit. So it's another point database job, but it's a specialized version of the point database job. And I believe we have I think on our YouTube channel, we do have a dedicated video all about just this job. So this is going to be a real scratch of the surface on the best fit job. But what this allows us to do is to use a local ground coordinate system with completely arbitrary coordinates. So it's based on a physical pin in the ground and a survey grid that was mapped out without any regard for where true north might be, without any regard to any other coordinate system. It's just, here's our grid, it's on the ground, it has no control. After the fact, that can be surveyed. So we have our control coordinates, and we have, we have our local ground coordinates, and then we have corresponding geodetically controlled coordinates. And in this case, we have some UTM values. They could be lat long, they could be geocentric coordinates that we reduce down to lat long or something like that. Two sets of coordinates that map up your local coordinate system to the real world in geodetic language. Very much like the process of georeferencing a raster or vector image. So we have an arbitrary position and a known geodetically based position. The point database best fit job allows you to map those up against each other and establish a transformation that you can save into the calculator for use in any of the other jobs. So you map up your local coordinate system, and then you can apply it to a PDC conversion for other data that doesn't have control with it. You can use it against AutoCAD files that have been created in that local system with data going straight from the surveyor into an AutoCAD-based system. It's really a feeder for the other job types. This is something that not everybody is going to use, but particularly folks that work in, say, mining grids or surface survey grids, engineering drawings, and so on, that those folks are going to very powerfully use and rely on day in, day out. So that's why this isn't everybody's number 5. This is one of my favorite parts of the application, and it really reduces the complexity of things that used to take a long time for folks to come up with these more hodgepodgey ways of making a transformation for local coordinates. If you'd like to see a lot of detail on this, I believe we do have another video on our YouTube channel dedicated just to the best fit, because it is a little involved in setting these up, and there's a lot of math to talk about that goes on behind the scenes. Well, what would you add, Scott?
Well, we are working on some enhancements to best fit, so stay tuned for an upcoming version of Calculator. The user's question was talking about, how did he put it? Linear corridors, and there's something called snake grids, and we're considering those sorts of things. So we don't know exactly what's in store for best fit, but we are working on some new stuff.
Yep, that's a good one. We've heard from a few folks talking about snake grids, like Scott mentioned. If you are a user of snake grids and you'd like to see those, we would love to hear from you. We're taking a look at whether or not that makes sense for us to add to the calculator. So if you think that would be a useful tool, please let us know. And I think we've reached our time here, Scott. So we'll handle some questions. I see. Let's see, Bruce is asking, what is a good reference to learn more about projection systems and coordinate conversions? We actually teach a class on this here at Blue Marble. We found years ago that simply telling folks how to operate the calculator sometimes needed a little more detail on the geodetics behind the scenes. So we do actually have a class that we call Applied Geodesy. I teach that, and Scott actually helps me. We teach that online a few times a year. We actually do have one of those coming up this spring. So if you take a look on our website, we'll be sure to send you a link. But if you take a look on our training website, you'll find some links to that upcoming training. There are a number of books that are out there to support this. One of the sort of very common places that I would recommend if you're a user in the United States in particular, or actually I'll say all of North America, is the National Geodetic Survey website. They have some good videos and sort of general references explaining the sort of common use of datums on this continent, and how we use some of these coordinate systems. What exactly is a datum, and a lot of the terminology that you'll bump into. There are some good references on sort of basic videos that you can find simply by searching YouTube. If you're looking to jump into the sort of the deep end of the pool, there is a book by a very well-known geodesist named Roger Lott about projections and coordinate systems, and that's a very academic take on coordinate systems and geodesy in general. Also, there is a group called the Americas Petroleum Survey Group, and if you are in the seismic industries, if you're in anything related to oil and gas exploration, that's a good educational group to look up. There are resources and users there that share information about how to stay out of trouble with all of this kind of stuff. But certainly, if you're very new to geodetics, I would recommend our own class, which is coming up soon. We take a kind of user level approach to it, the things you need to know in order to safely keep yourself out of trouble while doing geodetics within GIS and those sort of confines. Let's see here. There's a question on support for an FME extension that we had for GeoCalc. That was a tool that we had years ago, and never really took off. It was basically a tool that allowed us to use our GeoCalc engine under FME. That's not something that exists on the market anymore. We do integrate GeoCalc with our own Global Mapper application. Global Mapper, again, supports over 300 formats of data. And by tying the calculator up to Global Mapper, it allows very powerful transformations that can be accessed through scripting in Global Mapper and various, very powerful ways to combine large workflows. That is probably where I would steer you for now, if you're looking to go onto a more sort of more comprehensive, large, complicated integration. If you are a software developer, we do also have GeoCalc itself is the underlying coordinate engine used in Geographic Calculator. That is available in cross-platform kits from anything to conventional sort of C++ to C#, and then Linux builds, Mac builds, and so on. Any of the sort of common programming languages. Let's see, can we batch execute it? I see it now coming in as a follow-up. Geographic Calculator does have a simple command line interface using a batch execution. What is required for that is writing your own job file in Calculator. So all of the job files have their own extensions. You can get into those. Basically, it's JSON under the hood. You can fire those off on a batch execution. You can also use the Global Mapper side for Python scripting or Global Mapper scripting to run batch execution in little different ways, a little more nuanced control of that. All right, I think we have come to the end of the questions that we've had in. So if you are a brand new user and you're looking for a little more, we do have that Applied Geodesy coming up this spring. Those do usually fill up fairly full. It is an interactive course. We do some baseline geodetics, the sort of the science side of things, and then we get into the Geographic Calculator itself in depth, more than we have time for here today in one short hour. So thank you all for attending today and listening to us, and thanks, Scott, for joining me as well.
My pleasure. Have a good day, everyone.
All right, we'll see you next time.